So thank you for to the EDRLab for having inviting me here. I'm Gregorio Pellegrino. I live in Turin, which is the city of the Juventus Football Club in the north of Italy. Yeah, quite near France. One thing is that my parents founded a publishing house in 1995, and I studied computer engineer, so I'm half a publisher and half a computer engineer, so I think I'm in the right place here in the Digital Publishing Summit. Okay, I work as Chief Accessibility Officer in Fondazione LIA, which is a non-for-profit organization that was founded by the Italian Publisher Association and the Italian Blind Union. And our goal is to enable people with visual disabilities. And within the foundation, we do some research and development projects. For example, we have developed a connector for smart speakers for integrate our catalog of accessible ebooks in both Alexa and Google Home. And within these projects, we have done last year a research project, which is a pilot test with the University of Siena, which is a university in the center of Italy, for using image recognition for describing images to visually impaired people. The work was made with Tommaso Dringoli, who is a master's student in the University of Siena. The idea was to use some technology used by other big companies in the market, but to use it for the publishing field, since in publishing, images are very complex, and usually these algorithms and IA tools works well with photographs, but don't work well with complex images, graphs, and all the complex figures that are present in books. So why did we make this project? Blind people can't see images, so they need an alternative description to get the meaning of the content. And the alternative description can be accessed via the Braille display, like this one, or via text-to-speech or speech synthesis. And having alternative description for images is a requirement for creating accessible EPUBs, as described in the EPUB Accessibility 1.0 guidelines, and where it is written that in case of image content, the provision of alternative text is sufficient for meeting the requirements of EPUB accessibility specification. So the goal is to get from this first line of code where there is no alternative description to the second line of code with an alternative description automatically. So using some tools available on the market to understand what there is in the image, we will be able to create an alternative description automatically. One important thing is that alternative descriptions are different from captions, since captions usually, for example, in this case, the caption is Fernando with his sons Cesare and Rinaldo. Instead, the alternative description should be something like a black and white old photograph with 4 people sitting and looking at the camera. So it is completely different because the alternative description tries to describe the figure itself. Instead, the caption adds some context to the image. And one problem with alternative descriptions, as Luca Drain said before, is that it requires some times for editors in the publishing house, and usually editor doesn't have time for creating an alternative description, but it also requires some specialized training, because you need to be trained to create some good alternative descriptions. In LIA, we create alternative descriptions made of two parts. The first part is the image category, for example, photograph, chart, graph, and comics and other types of categories. We will see it after in another slide. And the second part of the description is the description of the image itself. So we try to find an AI solution for creating both the image category and the description of the image. Many of you knows, I think, that there are different tools available in the market for creating automatic alternative description. One is embedded in the last versions of Microsoft Office softwares, so in PowerPoint and Microsoft Word. Did you test it? Okay. How it works? It works quite well with images, with photographs, I mean, but it doesn't work well with all the other kind of images as far as I tested. Also, Facebook as a tool, every image that is uploaded on Facebook, it is ingested from their tool to create an alternative description, and it is quite good, but it is not available. I mean, it is open source, but it is quite difficult to compile. And then there are some APIs, for example, Seeing AI, that is from Microsoft, that is an app for getting information about the context in which the visually impaired person is. So our tool is an automatic alt text remediation for Epubs. So we start with images without the alt text. We ingest them with the alt text generator, and then we create a description that is made of the two parts, so the category and the description. So for categories, we use these categories, are 12. We have art, comic, complex, cover, drawing, flag, icon, logo, map, photograph, signature, and text. And what we did is, what we tried to do is to put a new image in the proper category. And we did it using the Google Cloud AuthML Vision, which is a tool made available by Google, where you can upload some photo datasets, and the tool auto-train itself. And so after the training, you can query the tool with a new image, and the tool will return the correct category, hopefully. So we started with this data set of 1,000 images per category. The 80% of the data set was used for the training. The 10% the data set were used for optimize the model. So it is the validation set. And the other 10% were used for evaluate the model, so the test set. These are the results of the training, where you can see the recall, the score threshold, and the other score threshold. That is quite good. So with this tool, we were able to create the first part of the alternative description, the image category. Then we tried other tools for creating the second part of the description, which is the description itself. We've tested different tools that are available in the market, but most of them returns only keywords and not a description. so not a description that can be read by human people. And other problems are that some of them are really, really expensive. So we selected two services for describing different kind of images. The first is the Google Cloud Vision API that is different from the other service from Google that we use, the AutoML. And we use the Google Cloud Vision API for the OCR, for logo recognition, for matching web entities, and for information retrieval. And we use the Microsoft Computer Vision for the description of images, photographs, drawings, and other kind of images. So for the different categories, we use different tools. For art, drawing, icon, and photographs, we use the Microsoft Computer Vision for generating the description. For the flags, we use the Google Cloud Vision API, matching with entities on web. So starting for a flag, we matched the correct web entity. For cover and text, we use the Google Cloud Vision API for OCR. For logo, we use the Google Cloud Vision API for matching with the web entities of the company. And for comic, complex, map, and signature, we decide to not create a description because the results from the different tools were too random, and they don't make any sense. So the process of the tool works in this way. We ingest an Epub file, and we extract all the images. Then we upload the images to the Google Cloud AutoML Vision for getting the category. And from the different categories, we use Google Cloud Vision API or the Microsoft Computer Vision for creating the description. Now I will show you some tests. And as you can see, some are good and some are not. But this is the goal of our research project, understand the state of art of these tools available on the market for using them in production, maybe in future. So this is the first image. It is a cover. Yes. But the description was created from the OCR, and it is not really good, since the font on the cover, it's really an handmade font, so Google can't understand it. Then we have this other image, which is a logo. Yeah. And the description is red Twitter. Yeah. Okay, we have another logo, which was categorized as a text. It is not correct, since it is a logo. But the description was fine, è fatta editrice. Good. Okay, then we have this photograph, and the description is a man looking at the camera, which, I mean, it is a man, but he is not looking at the camera, so I don't know if it is correct or not. I think it is quite correct. It is better than nothing, so it is okay for me. Then we have this other cover, okay, and the description is good, since the font is really strict. Then we have comic. Okay, the category is good, and we don't have descriptions for comics, since it's too difficult to describe a comic. We have this other photo. Okay, and the description is fine. A person wearing glasses and smiling at the camera. Yes. Then we have this really, really strange result. It was categorized as a drawing. I think because it is on black and white, maybe our data sets are not so accurate. But the description is really funny, since it says a vintage photo of John Ericsson, but he is not John Ericsson, posing for the camera. So it completely fails. Then we have another similar photo. It also says drawing, which I think the problem here is the data set. But the description is fine. A vintage photo of a group of people posing for the camera. Yeah, it's good. Then we have a map. Okay, it's fine. And we don't have a description for maps. Yeah, and then we have a title page where it recognizes it as text, and the description is fine. Is the OCR of the text. Okay, so which is the overall accuracy? The description is about 50% accurate, so that is good. But the category, it is only 42%, but we can improve it with better data sets for training the model. For example, with drawings for black and white photos. What our idea is to try to improve this algorithm, for example, using some natural language processing tools for getting the context in which the photos are inserted, but it will complicate all the work a lot, so we are really thinking if do that or not. Any suggestions or questions?
Questions? It was an amazing demonstration.
Okay.
I've got a question. Do you think that you will go on with this research development for several semesters? Because I'm pretty sure that each 6 months you will see amazing improvements in some areas.
I don't know. It's a matter of budget. This was a research project made with the University of Siena. So if we have other researchers or other students, we can try to improve it and test it maybe within 6 months or 1 year.
Okay, so when you have given some money to Epub, just think about.
Okay.